A massive space rock impact may have kickstarted Earth's magnetic field. The interplanetary collision that formed the Moon might have more connections to Earth's ancient history than we ever imagined. The protective magnetic field surrounding Earth is so strong that it must have formed early in our history. But there's a complication to timing that. Earth likely got whacked by a Mars-sized protoplanet 4.5 billion years ago. That crash may be connected to how our magnetic field was formed. The interplanetary collision was so colossal that it created gobs of material that formed Earth's moon, according to the giant impact hypothesis of the Moon's origin story. Scientists have been studying isotopes, types of elements, meteorites, and geology for decades to constrain the Moon's formation, but the magnetic field hypothesis is not as thoroughly explored. Earth generates its magnetic field through a geodynamo process, which requires a planet to rotate at a certain speed and have an interior fluid that can conduct electricity, among other properties. Earth's molten iron outer core is where the conversion to electrical and magnetic energy takes place. The field is self-sustaining, as the magnetic field induces electrical currents, and the currents generate a magnetic field. But how that process got started in the first place is poorly understood. In their paper, the authors say these are key questions that must be asked in future research to constrain if the strong field existed before or after the impact. What are the conditions under which disk accretion leads to the formation of a strongly magnetized protoplanet? What kinds of impact will leave a liquid core strongly magnetized? Conversely, what kinds of impact can lead to the strong magnetization of the liquid core? Can the removal of the crust and/or mantle by a giant impact create the conditions for vigorous convection in the core? Can the instabilities driven by rapid angular momentum loss of rotational speed lead to strong magnetization of the core? Can the recondensation of accretion tori, in other words, the coming together of the donut-shaped accretion disk after the impact, lead to dynamo action?